Hello everyone, today I'm taking a look at a very special esoteric programming language called COBOL. COBOL is a programming language which is mostly known for its English-like syntax. Released in the 1960s, COBOL was designed to create a portable language for data processing used primarily on mainframe computers in business, finance, and administrative systems. COBOL's background is actually very interesting. I recommend reading its Wikipedia article. Just like Fortran, there were several standards released, from the first one called COBOL 60 all the way to COBOL 2023. Nowadays, there are three major implementations: IBM COBOL, Microfocus Visual COBOL, and GnuCOBOL. Of course, the first two are commercial implementation, while the other is free and open source, which is the one I use. GnuCOBOL, as it says on its website, transpiles COBOL to C, which is then compiled to a native executable. Since it compiles C code, it is possible to use any C library from COBOL without the need of bindings. Aside-wise, I'm going to use raylib. As for the game, as you saw at the beginning of the video, I decided to make a mix between Space Invaders and Breakout. I realized a game like this will be simple enough to make in a language like COBOL. Let's take a look at raylib's Hello World program, which must open a window and show text on it. You'll notice that a lot of stuff that are mandatory in all COBOL are optional in here. For example, the first 6 columns can be used to write the line number or be left empty. Comments start with an asterisk at column 7, or you can use asterisk and greater than to start at any column. These have to be followed when using the fixed format, which is what I use. You can pass the parameter free to the compiler, so you can use the free mode in which you don't have to follow those rules. So here's the same program with the free mode, and as you can see, the program can start at any column and also the comments. Another thing is that the program, just like any other high-level language like BASIC, the variables and the keywords are case insensitive. Programs are divided in divisions which can contain sections. So first we have the identification division, which contains the name of this program. It's possible to add more information like the author's name, the date of compilation of the program, and much more information, but all of that is considered obsolete in most COBOL compilers. Data division contains the variables used in the working storage section. So the variables are divided into levels, which goes from 1 to 49. It must start at 1, and every time you group variables, you have to increase the level. From what I've seen, it is common to increase it by 5. There's also special levels that we'll look in a moment. So first you have to write the level, the name of the variable, which as you can see can use hyphens, pic or picture, and the format of the variable. So here 9 stands for a digit. For example, in this case, this is a variable that contains numbers from 0 to 9. So in this case, this is the same as writing 3 nines, which is a variable that goes from 0 to 999. And you have case which you can add an s to add a sign variable. So this variable goes from -9 to 9. And you can use x as a character. So in this case, this is a string that contains 3 characters. So as I said before, variables can be grouped. So for example, here PG color doesn't have a pic because it is not a variable, but is the name of the group of these 3 variables, the R, G, and B colors. And then we have the procedure division, which contains the procedures with the code. In COBOL, these are called paragraphs, which contain sentences. So here you can use call to execute C functions, specifying the parameters until if they are passed by value or by reference. And you can even have exception handling in case this call to a C function fails. Note here that end call and almost all end something in COBOL are optional. My convention is to use it when I have to split this call into multiple lines. So here we have perform, which is used for looping and executing procedures. So here in this case, this is the main loop. We perform until this variable equals 1. You can see how if you never used COBOL before, you don't really have to learn it because the syntax is pretty much speaks for itself. So there is one limitation in COBOL that its variables can contain numbers or text. But how can we pass a C struct like raylib rectangle or call? So notice here when we are compiling the game, we are passing a C file because COBOL compiles this COBOL script to C. So we can easily pass also a C file. In this C file, we have a static array of rectangles and a static integer which contains the index of these rectangles. So every time we create a rectangle, we add it to the static array, and then we return the index of that rectangle. So that way, from COBOL, we can control and pass these rectangles to raylib functions. So from COBOL side, to get a value from a C function, you have to call it and add returning and the name of the variable. So the rest of the code is like glue code. So for example, we modify this function draw text. So instead of taking a color struct, it takes the R, G, B, and A values in separate variables. And here we create the struct from C. Okay, let's take a quick look at the game's code. And instead of walking through the entire codebase like I usually do, I will only show you certain parts showcasing how to do certain things in this language. So the first thing you'll notice when looking at the game's code is this line, which is actually a preprocessor line. So COBOL has a preprocessor, but it doesn't exactly work the same as C preprocessor because you can use this name in an expression. So for example, you can put the value as this variable because it won't work. So what this is used is, for example, to conditionally compile code depending on the value. So you can use if debug is equal to 1, then I draw the FPS of the game. If it's 0, then I don't draw the FPS. So another thing you will notice is that all of this copy, which is called copybooks. The copybooks are used to split the code into different files. So my convention was to use these data values to store different variables. And at the end of the code, you have the different copybooks used for the procedures. So here in the background copybook, you have two procedures, one for initialize the background and another for drawing the background. And the same with the player, the ball, the missile, and the enemy. So here's one of the special levels of the variables I was talking about earlier. ATN is one of them. So the ATN level is used as conditions. So here, depending on the value of game state, all of these different values are going to be true or false depending on the value that is set. So for example, if game state is 1, which is the game is idle, then this variable is going to be true and all of the others are going to be false. So this is used, for example, when using evaluate, which is similar to switch in the C language. So here we're looking for the variable that is true. If it is this one, then we perform this procedure, and so on. So the level 68 is simply used for compile time constants. So this is the one that can be used in expressions. So for example, here you can see that I have a variable for the amount of enemies, and this variable is used here which is used to define an array of rectangles that is used for each enemy. So here we have an array that, well, here is how you define an array in COBOL. You say occurs a number of times, and you can even define the index of this array. So in this case, this simply define a variable with this name and with a default picture, but you don't have to necessarily use this index. You can use any index you want. But this simply just creates a variable that is prepared to index this array. Another type of special variable is the floating point variables, which is called computable or comp1. So all of these variables are floating point. You can see here that you don't have to specify a picture. You just simply have to define the usage comp1, and that's it. So here's the init enemy procedure in which we create the enemies. So here we have to perform a loop to create the enemies in the array, and this is done by writing perform varying enemy I from 1 by 1. So this is the start value and the step value until this condition. So here we create a rectangle by calling this special function, which is defined in the C script that I passed to the COBOL compiler. So this creates a rectangle inside the static array and returns the index of that rectangle. So here I save it to the array defined in COBOL. So one thing to notice here is that you can use the verbose way of writing code. Instead of use the symbol greater than, you can write the words, but you can also just write the symbol, which is, in my opinion, easier to read, and I believe most COBOL programmers don't really use this syntax anymore because it's mostly just way too verbose. But I use this just to show that it works the same. So another thing you have here is called intrinsic functions, which is built-in function that COBOL provides. So for example, mod is one of them. Another one is random that I use in another part of the code. And these are simply functions that can be called by writing function, the name of the function, and the different parameters. So here's another thing that happened to me that COBOL code allows, but it doesn't actually work the way you are expecting. So for example, in this procedure, update ball, if this variable is true, then we do this procedure. Otherwise, if this variable is true, then we do this procedure. So you'll notice here that it's a really weird way to write in this code. So in a regular programming language, you write an else if, and you will call it like this, right? So this makes much more sense. But the problem with this is that COBOL doesn't have else if. This is just else and if nested. And since the syntax is permissive, you don't actually have to write an end if to this if, because this one, I believe, since this is just a single line, you don't have to specify an if. So in this case, this doesn't really matter. This can be written like this, and it will work the same. But the problem is that you have several chain else if, so that doesn't exactly work as you would expect. So for example, here I'm detecting which part of the enemy the ball hit, so I can bounce the ball accordingly. So this is how you will write it in a regular programming language. But as I said before, COBOL doesn't have else if. So this will be, if this condition is true, then we do this. Otherwise, if this condition is true, then we do this. Otherwise, but this is not written this way. But this will be a lot of if, else, and then a nested if, else, and then another nested if, else, and so on. So the way to write this code in particular is to use an evaluate true. So in here we write different conditions and we execute the code accordingly. So this is how you multiple ifs. So one last thing I want to show that COBOL complains when we allow all of the warnings, and most COBOL programmers agree is a bad practice, is the use of this archaic word next sentence. So what this does is like a go to the next sentence, and the next sentence is defined as the following sentence from this period. So what this does is to seek this period and continue executing from this period to the next line. In this case, it simply just skips this whole procedure. So I pretty much use this as a way to exit from this procedure in the case this condition is true. Or, for example, if we're in a loop and we don't want to continue in this loop, I just simply call next sentence. And since the only period in this procedure is defined at the end of the line, at the end of this procedure, so it works the same. As I said, most COBOL programmers believe this is a bad practice, and COBOL itself says this word is archaic, but it really works the same. So I believe it doesn't really matter. I just simply use a few times and that's it. So that's pretty much all I wanted to show about the game's code. The language is really easy to learn because that's the whole point of this language, to be easy to learn for anyone, for both programmers and non-programmers. But my main problem is that I didn't use the free format, so I have to follow the very old COBOL syntax, which is starting at a specific column, and the line has to fit into 72 characters, otherwise you have to break your line into multiple lines, and that's a bit of a hassle, but yeah. Nowadays, there's really no point into using the fixed format. It's really annoying unless you are maintaining all code which use the fixed format. But nowadays, it doesn't really make sense to use it. And writing the verbose way as I did also doesn't really make sense. So yeah, I wrote the code in the old-fashioned way just because.